All right, guys. So we're going to finish up the note sheet today. The other part of solving these rational equations. So we're going to finish up solving these rational equations. Thank you. Now, before we start solving this here, we do need to make sure that the denominators are factored completely, because if they're not factored completely, we might multiply by the wrong thing and make these harder to solve. Now, out of all three rational expressions in this equation, the last one, the x plus 3, is already in simplest form. Now, we do need to factor the other two. Now, the first one, x squared minus 9, is a nice one to factor because it is a difference of perfect squares, which would make it be x plus 3 and x minus 3. Now, the only one we have left to factor is the x squared minus 6x plus 9. Since the third term is positive, the signs are the same and match the sign of the middle term, so we'd have negative and negative. Factors of x squared are x and x. Now, the factors of 9 that we have are 1 and 9 or 3 and 3. Here we would use 3 and 3. And if we did check this here, x times negative 3 is negative 3x. Negative 3 times x is negative 3x, which does give us a middle term of negative 6x. So those are the correct factors. Now, we do need to check for restrictions. And out of all three denominators, there's really only two expressions that we have. We have x plus 3, and we have x minus 3. And in both cases, neither one of these can be 0. So we can set it equal to 0 and solve. And for the first one, it works out that x cannot be negative 3. For the second one, we add 3 to both sides, finding out that x cannot be positive 3. So if we have an x value of positive or negative 3, it would be one of our extraneous solutions. It wouldn't work, and we would throw it out. Any questions on this so far? Now, what is one thing we know we'll need to multiply all three of these rational expressions by? X minus 3. And the one on the far left, the x minus 3, would cancel out with one of the x minus 3s. The one in the middle. Yes. Because since the denominator in the middle has 2, we're going to need 2 of them. So that means we're going to have to multiply each one of them by an additional x minus 3. So that these two will cancel. Put parentheses around that. Are all the denominators simplified? No. What else do we need? X plus 3. Now in the far left one, the x plus 3 and x plus 3 would cancel. In the middle, the x plus 3 stays there. And in the last one, the x plus 3 and x plus 3 will cancel. Now let's see what we have left over. So on the far left side, we do have the 4x times x minus 3. Because one of the x minus 3s did cancel, the x plus 3s canceled, so all that we left to be multiplied in the numerator is the x minus 3. In the middle, what we started out with on top of the fraction is x minus 1. Both of the x minus 3s did cancel out, but we were still left with an x plus 3. Plus 2 times The one x plus 3 did cancel out, leaving us with what? X minus 3 and x minus 3. Did those come from a specific location? Where did both of these come from? X squared minus 6x plus 9, yes? So what should they multiply back together to be? Minus. Now we could, again, have rewritten it out as x minus 3 times x minus 3. There would have been nothing wrong with that. And if we distributed, x times x would have been x squared minus 3x plus 9, which would have given us x squared minus 6x plus 9. We would have gotten back to the same thing. Any questions on any of this here? Now at this point here, we do need to distribute and simplify. So on the far left side, we're going to distribute the 4x. 4x times x is 4x squared. 4x times negative 3 is going to be negative 12x, is equal to. In the middle, we'll distribute x times x is going to be x squared. X times 3 is going to be plus 3x. Negative 1 times x is going to be negative x, and negative 1 times 3 is negative 3. And in the last set of parentheses, we'll distribute the 2. 2 times x squared is going to be 2x squared. 2 times negative 6 is negative 12x. And 2 times 9 is plus 18. Now on the right-hand side, we do need to add like terms. X squared plus 2x squared is 3x squared. 3x minus x is 2x. Minus 12x is negative 10x. And lastly, negative 3 plus 18 is plus 15. Any questions on how we got to this point here? Now we do need to get everything on the same side of the equal sign. And I like to try to keep the x squareds positive. So I would subtract 3x squared first. 4x squared minus 3x squared is going to be x squared. Minus 12x is equal to negative 10x plus 15. Next we can add 10x to both sides, which will give us x squared minus 2x is equal to 15. And last but not least, we can subtract 15 from both sides. Giving us x squared minus 2x minus 15 is equal to 0. Any questions on this here? Now at this point here, we can factor this. Our two sets of parentheses. Since the 15 is negative, our signs are opposite. One's going to be positive, one is going to be negative. Factors of x squared are x and x. Now the factors of 15 are 1 and 15 or 3 and 5. Which one do we want to use? 3 and 5. Which one's positive? Which one's negative? 3 is positive, 5 is negative. Now it does tell us that x plus 3 is equal to 0, and x minus 5 is equal to 0. Because when we multiply two things together and get 0, one of them must be 0. And we can solve. And we subtract 3 from both sides, we see that x is equal to negative 3. And when we solve for the other case, we add 5 to both sides, telling us x is equal to 5. Any questions on this here? So our solution for this is what? X equals 5, yes? What about x equals negative 3? It's one of our restrictions, so it is not part of the correct answer. It's one of our extraneous solutions. So the only correct answer for this here is x equals 5, because we had to throw x equals negative 3 out. Any questions on this here? We ready for the next one? Now looking at this one here, out of all 3 denominators, there's only one of them that we actually do need to factor. The other 2 are fine. X minus 2 in our first one is fine. The x plus 2 in the second one is fine. However, we do need to factor the x squared minus 4. Now this is a difference of perfect squares, so that's nice, because this will factor 2, x plus 2 and x minus 2. Now we do need to find our restrictions. The 2 places where the denominator can't have a value of 0 is with our x plus 2 and x minus 2. Now for the x plus 2, we would subtract 2 from both sides, telling us when x is negative 2, we would have a 0, so it doesn't work. In the other case, we would add 2 to both sides, telling us that if x was positive 2, we would get a denominator of 0, so it doesn't work. So our 2 solutions that we cannot have are positive or negative 2. Now what do we need to do next to solve? So multiply them by? Yeah, x minus 2 and x plus 2. Because we're multiplying them by x plus 2 and x minus 2 so that we get these fractions to simplify. Because in the first one, the x minus 2 and x minus 2 would cancel. The one in the middle, the x plus 2 and x plus 2 would cancel. And in the last one, both of them would cancel out. And what that leaves us with is 9 times x plus 2 plus 6x times x minus 2 is equal to 9x squared. Any questions on this so far? Now we'll need to do some distributing and then simplifying. So here we can distribute the 9. So 9 times x is going to be 9x. 9 times 2 is going to be plus 18. We can distribute the 6x. 6x times x is going to be plus 6x squared. 6x times negative 2 is going to be negative 12x is equal to 9x squared. Now we can combine like terms on the left-hand side. 6x squared is the only term with x squared. However, 9x minus 12x is going to be negative 3x plus 18. Now we do need to get this equal to 0. However, trying to move everything over to the 9x squared is going to take 3 steps. It's going to be a little bit easier this time to just subtract 9x squared from both sides. (6x squared minus 9x squared is negative 3x squared. Minus 3x plus 18 is equal to 0. Any questions on how we got to this point here? Any questions on any of this so far? Is there a greatest common factor between these three terms? 3. So what I could do is I could divide every single term by 3, yes? But unfortunately, what is the number in front of x squared? It's not positive, it is. So I can actually do negative 3. I do negative 3 because having that x squared positive makes these easier to work with, makes these nicer to work with. So we can divide it by negative, which will give us x squared. Let me write x squared. Negative 3 divided by negative 3 is positive 1. 18 divided by negative 3 is negative 6. And 0 divided by negative 3 is 0. Now this seems like a very odd thing to do, or that this would work at all. But if we look at the graph, negative 3x squared minus 3x plus 18. So this here is our original graph, and it goes down. That makes sense. Since a is negative, it would go down. Now, once we divided by negative 3, we got x squared plus x minus 6. And the one in red does go up. Everything on the graph did change, except for the 2 spots where it crossed the x-axis. So dividing by that negative 3 doesn't affect the solutions. It affects everything else. But it doesn't affect the solutions, and it does make it easier to work with. Because x squared plus x minus 6 is a lot easier to factor, a lot easier to solve for than negative 3x squared minus 3x plus 18. Would you all agree with that? Now all we need to do is to factor. Since the 6 is negative, our signs are opposite. Factors of x squared are x and x. And what factors of 6 do we want? 1 and 6 or 2 and 3? 2 and 3. 3 would be positive, the 2 would be negative. Since we have 2 things multiplied together to equal 0, one of them must be 0. At this point here, we can solve. So we'd subtract 3 from both sides, telling us x is negative 3. And for the other one, we would add 2 to both sides, telling us x is equal to 2. And we find that our 2 solutions are negative 3 and positive 2. However, one of these doesn't work. X is equal to 2 does not work, so that means x is equal to negative 3 is our only solution. Any questions on any of this here? Any questions over anything we've done so far? We feel pretty comfortable with these here? Yes? We're going to look at one last one, and then we will be done with this here. Now this one here, just like with the previous ones, we do have one of the expressions in the denominator that we do need to simplify. So we need to factor the x squared minus x minus 2. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. And the factors of 2 we want are 1 and 2. Which one's going to be positive? Which one's going to be negative? 2 is negative. Because to get the middle term of negative x, we need it to be x plus 1 times x minus 2. Now this time, unlike the last ones, we do have 3 different spots where we could have a 0 in the denominator in the bottom of the fraction. Because we have it for the x plus 1, the x minus 1, and x minus 2. Now for x plus 1, we can subtract 1, telling us x cannot be negative 1. For the x minus 1, we add 1 to both sides, telling us x cannot be positive 1. And lastly, we can add 2 to both sides, telling us x cannot be positive 2. So the 3 solutions, or 3 values of x we cannot have are negative 1, 1, and positive 2. Questions on this here so far? Now to start solving, we do need to simplify these rational expressions by multiplying it by the least common denominator. So one of the things we do know that we'll need to multiply everything by is x plus 1 and x minus 1 for sure, and x minus 2. X plus 1, x minus 1, x minus 2. And going from left to right, in the first one, the x minus 1 will cancel out with the x minus 1. In the middle one, the x plus 1 will cancel out with the x plus 1. And the last one, the x plus 1 and x plus 1 would cancel. X minus 2 and x minus 2 would cancel, leaving us with 2 times x plus 1 times x minus 2 plus 1 times x minus 1 times x minus 2 is equal to x minus 1. Any questions on this here? I did write one of these out that we didn't necessarily have to write back out. Because where do we get x plus 1 times x minus 2 from? The x squared minus x. So we could rewrite it out that way, or we can go on and keep distributing. X times x is x squared. X times negative 2 is negative 2x. 1 times x is plus x. And 1 times negative 2 is negative 2. We can distribute the middle. X times x is x squared. X times negative 2 is negative 2x. Negative 1 times x is negative x, and negative 1 times negative 2 is plus 2, is equal to x minus 1. Now at this point here, we can simplify or combine like terms, especially inside the parentheses, because negative 2x plus x is negative x. Now the second set of parentheses here, since there's no number in front other than 1, we don't have to keep them there, and especially since it's plus, the signs are not going to change. Negative 2x minus x is negative 3x, plus 2 is equal to x minus 1. Next thing we'll need to do is distribute the 2. 2 times x squared is 2x squared. 2 times negative x is negative 2x. And 2 times negative 2 is negative 4. Any questions on any of this here so far? Now at this point here, we can combine like terms. 2x squared plus x squared is going to be 3x squared. Negative 2x minus 3x is negative 5x. And negative 4 plus 2 is negative 2. Now that we do have both things, or both sides of this equation as simplified as we can get them, we do need to get it equal to 0. So the first thing we can do is subtract x from both sides, telling us that 3x squared minus 6x minus 2 is equal to negative 1. And then we can add 1 to both sides, telling us that 3x squared minus 6x minus 1 is equal to 0. Any questions how we got to this point here? Well, I can tell you most certainly this thing is not going to factor. So the easiest thing we can do is use the quadratic formula to find the solutions of this here. Negative b, because a is in front of the x squared, b is in front of the term with the x, and c is the number by itself. So negative b, so negative negative 6, plus or minus the square root of b squared, so negative 6 squared, minus 4, times a, which in our case is 3, times c, which is negative 1. All over 2a, or 2 times 3. Any questions on any of this here? Now our negative negative 6 and negative make a positive, plus or minus. The 2 times 3 in the denominator is 6. The next thing I would do is simplify everything inside the radical. I wouldn't take the square root of it yet, but I would want to see what this is. So in the calculator, we can do parentheses, negative 6 squared minus 4 times 3 times negative 1. And we get 48. Now the square root of 48 is nice because it does simplify a little bit. We can take the square root of 48, which is 4 square root of 3. Four square root of 3 and 6 have a greatest common factor of what? 2, yes? So one way we can think of this with reducing, we can factor it out. 3 factored out, or 2 factored out of 6 is 3. 6 divided by 2 is 3. 4 divided by 2 is 2. And what is 2 over 6 the same as? 2 over 6 is the same as 1 over 3. So really all we did was pull that 2 out to reduce it with the 6 on bottom to turn it into 3, or put it in simplest form. So it works out that this does have solutions of 3 plus or minus 2 squared root of 3 over 3. which neither one of those is our restrictions, but we do have this here. So we could have it as 1, but to do that we would need to split them in half, have it as 3/3 plus or minus 2 square root of 3 over 3, which would simplify to 1 plus or minus 2 square root of 3 over 3. Because we can't just simplify the 3 and 3, because the numerator is considering that to be one whole term. Now, I did this one here so that we could see that these rational equations don't always have nice number solutions like we've had so far. We can have these irrational solutions. But that's it. Now, all the ones on the homework are not going to be as irrational, have irrational solutions as that one there. But we still do need to look for restrictions. And that is the end of this here.